Where do birds come from? And who were their ancestors? For a long time, these questions have remained unanswered. Their family tree stopped abruptly at the oldest known species, a fossil found in 19th century Germany, Archaeopteryx, whose name comes from the Greek for ancient wing. But since 1996, thousands of animals unearthed in China have shed new light on the origin of birds. This abundance of discoveries proves that most dinosaurs were not covered in scales, but clad in feathers. Some of these feathered dragons could even fly. The extent of the Asian jigsaw puzzle is so vast that it ties modern-day birds to remarkable distant cousins and suggests a multitude of relatives. During the Jurassic period, between 200 and 145 million years ago, the supercontinent Pangaea opened up, creating separate landmasses. At the edges of this world, China and Siberia formed a huge peninsula with a temperate climate similar to that of modern Europe. The breakup of the continents was accompanied by volcanic eruptions, particularly in China. A paradise in waiting, inhabited by strange creatures, like Anchiornis. Meaning near bird. This little dinosaur is completely covered in feathers. The size of a modern-day pigeon, Anchiornis is a long-lost relation. The descendants of this lightweight dinosaur survived better than other large theropods, a group that includes all carnivorous dinosaurs. Including guanlongs. They are efficient hunters, 3 meters long and weighing 50 kilograms. To escape, Anchiornis was capable of short gliding flights, while its pursuer was firmly stuck on the ground. And yet, guanlongs also had feathers. What were they used for? Erupting volcanoes spewing fine ash and noxious gases froze a moment of Jurassic life for eternity, helping us answer some of these questions. This dinosaur paradise has become the feathered dinosaurs' Pompeii. A huge range of new species has recently been discovered in one of China's many construction sites. Over the last 2 decades, in the Liaoning region, paleontologists have collected thousands of specimens, hidden for millions of years. These magnificent fossils are in a state of almost perfect preservation, thanks to the mixture of extremely fine clay and volcanic ash sediment.
And those volcanic eruptions killed the animal directly and they buried their body. So that's why we have so beautiful skeleton and I include soft tissue preserved. So that's why we come here.
Paleontologist Xu Xing and his colleagues from around the world can trace the chaotic history of flight and feathers in these rocks.
The feather preservation is really amazing.
Like detectives, they examine the clues to understand what feathers were used for. And discover how some dinosaurs from the theropod family turned, over the course of millions of years, into birds. The first piece of evidence in their inquiry was discovered at the end of the 19th century in Germany. Towards the end of the Jurassic period, Europe was partly submerged under a shallow body of water called the Tethys Sea. About 150 million years ago, Germany was dotted with tropical islands. Pterosaurs, the first flying vertebrates, have dominated the skies for 80 million years. This is Germanodactylus, one of 150 species of pterosaurs discovered. These flying reptiles are not dinosaurs. A fine skin stretches over their elongated fingers to create leathery wings. This membrane, along with powerful muscles and hollow bones, makes them masters of the skies. But the pterosaur's aerial supremacy is about to be challenged by the very first birds, such as Archaeopteryx. A primitive bird whose claws at the ends of its wings raised suspicions amongst 19th century paleontologists. Its fossils were found around the modern German town of Solnhofen, a tropical archipelago during the late Jurassic period. Some islands harbored salty lagoons where dying animals avoided scavengers and were buried by soft mud that preserved them in minute detail. Eberhard Frey, commonly known as Dino Frey, is the resident expert.
This is the famous Solnhofen laminated limestone, and you can actually see the sediment stapled up like the leaves of a book. And inside the leaves of this rocky book, this is where Archaeopteryx was found together with many other fossils. And it's a speciality of this rock that it is very, very, very fine-grained. And inside this mud, fossils are preserved like in a tin. And this is why this entire area is so valuable as a window in Jurassic times.
The locals use these stones to tile their houses, in the process uncovering highly prized treasures in the history of paleontology. In 1868, faced with the Archaeopteryx, British biologist Thomas Henry Huxley asserted that this was a transitional fossil between reptiles and birds. A friend of Darwin and an ardent defender of the theory of evolution, Huxley was an expert anatomist, capable of skilled fossil analysis.
But until the year 1861, before Archaeopteryx was discovered, the only creatures that were known to have feathers were the birds. So it was apparent that this is a fossil bird. And Thomas Huxley looked at it very closely, and he discovered signs that this bird could also be a dinosaur, actually a carnivorous dinosaur, and actually shares characters of the two, making it a missing link between dinosaurs and birds. That was a sensation at the time.
The Darwinian idea of natural selection is therefore very recent. Huxley had the insight to see that Archaeopteryx's teeth, clawed wings and bony tail meant that it had similarities with Compsognathus dinosaurs, predatory relations of the velociraptors. Archaeopteryx was certainly no acrobat, but it had feathers, and it could fly. Its collarbones had already fused together, a vital step enabling the wings to flap efficiently and gain altitude, allowing it to hunt and nest in trees. Throughout the 20th and 21st centuries, more Archaeopteryx fossils were unearthed in Germany.
This is specimen number 11. It's the latest specimen, and it came to light in the year 2011. And despite it's fragmentary, it's not completely preserved because the skull is missing, it still shows us some features which were previously unknown. One of them is that the tail end shows a V-shaped feather configuration. And the second is that you can see in this specimen the extent of the feather troughs along the legs.
The feathers on its feet are intriguing, since modern birds no longer show this characteristic. Is this an exception? What is sure is that this feature has not been selected by evolution. Just like this giant marine reptile, a Leopleurodon. Washed up on the shores of the lagoon, it is a godsend for Archaeopteryx. The flies attracted by the carcass provide a hearty meal for this insect eater. But being out in the open is dangerous for Archaeopteryx. An opportunistic Germanodactylus sees the prospect of a protein-rich meal. And doesn't appreciate the competition. Once the mightiest creatures in the skies, pterosaurs became extinct by the end of the Cretaceous period, 65 million years ago, while Archaeopteryx's descendants grew in number. Bogged down at the bottom of the Solnhofen Lagoon, this remarkable fossil launched the debate on the relationship between birds and dinosaurs. But with insufficient proof, this theory was shelved for more than 100 years. Until new evidence came to light at the end of the 20th century in China. In 1993, in Liaoning, a huge fossil deposit was found dating from the Cretaceous period, 125 million years ago. This region, formerly known as Manchuria, comprises fertile farmland with fields of corn and pasture. Farmers were the first to uncover fossils inadvertently. In Sihetun, at the foot of a cliff fashioned by volcanic eruptions, layers of grey mud alternate with red ash. Transported to Beijing, these fossils allowed 21st century researchers new insights into the feathered dragons. Like Sinosauropteryx, the first discovered in 1996. This specimen remains a source of fascination for one of China's most famous paleontologists, Xu Xing.
I remember clearly at that time when this discovery was announced, everyone got so excited, we are kind of shocked by the beauty of the fossil. If you look at this specimen closely, you see the feathers cover the whole body, over the head, over the back, cover whole the tail, a little bit here also, limb. Basically, feathers are quite simple. They are more like your hair. Before this discovery, some paleontologists believe some bird-like dinosaurs should have feathers, but now we have real evidence, so that's totally different.
The discovery of this feather-covered fossil was astounding. For the first time, they had found a dinosaur with avian characteristics, proof that they were part of the same lineage. In conifer forests, growing in the shadow of volcanoes, lived Sinosauropteryx. It belonged to a group of carnivorous dinosaurs called theropods. These predators use sight and smell to hunt. One of its favorite victims is Zangiotherium, one of the first mammals. Sinosauropteryx feathers look like the down covering modern-day chicks. They are so different from bird feathers that for a long time, skeptics dismissed them as mere hairs. In 2010, Xu Xing focused on Sinosauropteryx' strange feathers, which look like the down covering modern-day chicks. He began with careful observation of these feathers. By taking a sample and putting it under the microscope, scientists discovered fossilized pigments. These are melanosomes, cells that give feathers their color. Xu Xing discovered circular shapes that produce a brown pigment and stick-like shapes that create a gray color. He deduced that Sinosauropteryx was the color of a squirrel, with lighter stripes on its tail, but that's not all.
We can use melanosome to infer the color, but more importantly for us, we want to use that information to support the hypothesis that those dark impressions in this particular specimen are protofeathers, not something else. Because if melanosomes are present, we can see quite confidently those are primitive feathers.
Sinosauropteryx was undoubtedly covered in feathers, but this land animal was incapable of flight. So what use was this dino fuzz? Did it protect this warm-blooded animal from the cold? Possibly. But this theory is not easy to prove. To learn more about the climate in Liaoning during this period, Xu Xing teamed up with a laboratory in France. This theropod tooth, brought back from China by geologist Romain Amiot, holds the key to this meteorological mystery.
A lot of researchers thought that fossils from that time couldn't preserve the weather conditions recorded during the animal's lifetime. It was a big challenge. We were going to test something unknown. Could we find out climate information or not?
In a sense, we can test the water that the dinosaurs drank. A chemical reaction with the oxygen preserved in tooth enamel reveals the temperature of the atmosphere 120 million years ago. Romain made a major discovery that radically altered our preconceptions.
At that time, there was a global climate that was similar or a little colder than current temperatures, which is very different from what we thought about the period of the dinosaurs that we had imagined as hot, tropical, and the same throughout the world. Where Liaoning is, the climate was similar to what we have in the north of France, with very harsh winters. So dinosaurs would have seen snow in winter. So feathers were an insulating material. It meant they could keep warm and keep active throughout the year, like any other warm-blooded animal.
Coincidentally, just as Romain published his research, the discovery of large-sized dinosaurs confirmed his work. Eutyrannus, the aptly named feathered tyrants, were the super predators of the time. Due to their large size, the remains of T-Rex's cousins are kept in a warehouse in a suburb of Beijing.
Eutyrannus is a really amazing animal. You know, it's a really big animal, about 1.5 tons in body mass. Its body covered by feathers, really long feathers. So this is unexpected. You know, traditionally we thought, you know, when animal get big, for dinosaurs same, those feathers, reduced feathers, or at least the feathers are kind of sparse. But here we have a large-bodied dinosaur with dense and long feathers. So this is bizarre.
The fact that such a large, warm-blooded animal was covered in feathers suggests that its body size was not sufficient to regulate its temperature. so the climate must have been very cold. The discovery of the largest feathered animal ever found confirms the hypothesis of a temperate climate with harsh winters. It proves that the theropod dinosaurs of Liaoning wandered into the winter snow 125 million years ago, and that the feathers of the little Sinosauropteryx and the huge Eutyrannus protected them from cold temperatures in this region of the northern hemisphere. The insulating property of feathers remains a feature in modern birds. But it is not sufficient to explain how surface-dwelling dinosaurs evolved over millions of years to become birds. Among the theropods living in Liaoning, was there only one type of feather? And at what stage did dinosaurs begin to fly? Over time, Chinese paleontologists have unearthed many feathered creatures. On some fossils, like the Caudipteryx discovered in 1998, Xu Xing found feathers that were not just simple filaments. With its large feet, it looks much like an ostrich.
In this fossil, there are some really beautiful feather impression. Here you see two hands of this animal, and here is the middle finger, and you see feathers attached to the finger, this surface, and they go this way, so it's quite a big feathers.
Caudipteryx, literally meaning tail feather, comes from the same Chinese site as Sinosauropteryx in the same period, 125 million years ago. Scientists imagine that these chicks were imprinted on their mothers, just like modern birds, and followed them everywhere, more or less. Weighing almost 20 kilograms, the female Caudipteryx can't fly. Neither can her youngsters. So why do these animals have long feathers? Could they serve a purpose other than warmth? Feathers begin as a simple filament, which divides to form a pom-pom before barbs appear around the hollow shaft. But at this stage in their development, feathers are symmetrical and air passes through them.
So it is not flying animal, it's fast-running animal living on the ground. So what's the function? Apparently those feathers are not used for flight. So the other possibility most people believe is display.
Just like many birds, the males and females were physically very different. Paleontologists believe that the male Caudipteryx displayed his shimmering feathers in order to attract females. These courtship rituals, along with natural selection, stimulated an anatomical transformation. Caudipteryx were among the first theropods to possess a shorter tail that supported their display feathers. In order to fly, they were still missing a fundamental element: flight feathers. Seen under a microscope, this feather comes from another dinosaur, discovered in 2000 by Xuxing himself. It is a vital clue to solving the mystery of the origin of flight.
Here, the feathers are highly asymmetrical. So asymmetrical feathers are normally considered to be associated with the flight capability.
These feathers are identical to those of modern birds. It may be proof that some dinosaurs could fly.
Microraptor is definitely the most amazing species discovered so far. It is a dinosaur, but you see it has asymmetric flat feathers, not only the feathers on the arms, but also on the feet. So we call it four-winged condition. This is really, really bizarre. And now we have quite good evidence suggesting this four-winged condition is related to the origin of flight.
For a long time, paleontologists believed that two-legged dinosaurs ran along the ground in order to take off. But Microraptor's climbing claws opened up a new possibility. 125 million years ago, in the part of China that Microraptor called home, the ground was fertilized by volcanic ash that encouraged the growth of lush vegetation. Tall trees add a vertical dimension to the landscape, and the Microraptor, meaning small thief, takes advantage of them. Microraptor sported feathers on its arms and legs. With its four wings, it was probably the world's first base jumper. Four wings offer an advantage for gliding, but not for walking. A Microraptor on the ground is a Microraptor in danger. According to Xuxing, tree-dwelling feathered dinosaurs like these would evolve to become birds. To better understand this transition, paleontologists teamed up with an ornithologist, Zhuzongge. In front of him is an incredible collection of primitive birds found at Xietun. Like the feathered dinosaurs from the same site, they all date from the Cretaceous period, 125 million years ago.
I think there are over 500 specimens of Confuciusornis are collected in this museum alone. I think this is the largest collection of Confuciusornis in the whole world. This bird, like Confuciusornis, they are only shortly later than the earliest bird, Archaeopteryx, and they are transitioned in many flight apparatus, many features.
Despite the claws on their wings, they are very similar to modern birds. They no longer have teeth or a long bony tail. They also have a furcula, the famous chicken wishbone, for attaching muscles to wings. And the males have two ceremonial ribbons ornamenting their behinds. This sexual variation is similar to that of the feathered dinosaur, Caudipteryx. Like him, the male has long feathers that he uses to lure the ladies. Competition is tough, and courting displays are often interrupted.
Also, you can see the bird start climbing the trunk with very big claws in the wing. Now you see the bird can perch on the branches of the trees because the helix of the foot is already reversed, much like a modern bird.
Confucius ornis's narrow feathers were not well adapted to gliding, but would have allowed it to fly by flapping its wings, albeit clumsily. But natural selection is at work, retaining only the most adept genes. Yet the presence of many birds found at the same location as feathered dinosaurs does not necessarily prove that they were related. If birds had already diversified 125 million years ago, Eutyrannus and other theropods may have been merely an evolutionary dead end. So when did the first birds appear? Did they share a common ancestor with feathered dinosaurs? And how did their ancestors begin flying? To answer these questions, Chinese paleontologists have one last card up their sleeves. West of Liaoning, a new fossil bed was revealed during the construction of a motorway. In 2009, a finely preserved Anchionis, dating from the Jurassic period, was found near here. It was to become a crucial piece in Shuxing's puzzle.
This site is very important for, at least for one reason. We know that Archaeopteryx, the earliest known bird, is from about 145 million years ago. But most other feathered dinosaurs are, from early Cretaceous or even later. So this dinosaur was living in like 160 million years ago, earlier than Archaeopteryx. So that means there are some feathered dinosaur predates Archaeopteryx, the earliest bird. So that's correct time sequence.
This new fossil puts an end to the debate. Feathered dinosaurs are undoubtedly older than the first birds. Today, Shuxing discovers a fish, confirmation that Anchionis lived in a rich ecosystem. This little four-winged theropod must have been a victim to giant predators. In the Jurassic period, pterosaurs, like these Darwinopterus, ruled the skies. With talon-like claws and a wingspan over 1 meter wide, they were the equivalent of modern-day birds of prey. Their ability to fly and perform aerial acrobatics was beyond that of the feathered dinosaurs. Faced with this constant danger, Anchiornis sought shelter in the forest. But this little dinosaur was also threatened from the ground. Its only shelter lies in the restricted area between the ground and the sky, the trees. It glides down to feed in the undergrowth. Its surface area is smaller than Microraptor, so it falls more quickly. With its long back legs, Anchiornis is built like a sprinter, but its lengthy feathers are a hindrance on the ground. Its long legs are an advantage for foraging or rushing to the nearest shelter, if such a thing exists. Clumsy, Anchiornis showed that dinosaurs attempted to fly from trees using 4 wings. On this rare fossil, the rear leg feathers are visible to the naked eye. To refine his theory, Shuxing continues his research using a medical scanner. X-rays of Anchiornis' skeleton will be digitized in 3D in order to study its biomechanics.
But honestly, there are some debates how exactly those animals use their leg wings. Some people believe the leg wings are not really related to flight. Maybe it's a display structure. If you look at other dinosaurs, their leg normally is underneath the body. They have sort of like fully erect posture. One possibility may be Anchiornis can project its leg slightly laterally.
To compensate for the lack of a wishbone, Anchiornis used its rear leg feathers to improve its gliding ability. The discovery of Anchiornis proves that dinosaur flight was a result of trial and error in the evolution of anatomy and feathers. Surprisingly, new information about the origin of feathers was soon to appear from over the border. In Siberia, in the summer of 2013, the first Russian feathered fossils made their appearance. "1,500 kilometers north of Beijing, in the Trans-Baikal steppe, a team of Russians and Belgians worked together at the excavation site. When local geologists found the first bones, they invited paleontologist Pascal Godefroy from the Royal Institute of Belgium to take part in this revolutionary discovery.
We're at the Kulinda deposit in southeast Siberia. The hills you can see behind me date from the Jurassic period between 145 and 160 million years ago. And Russian geologists who were prospecting in the area in 2010 found the first dinosaur bones, which have been extremely important for reconstructing the evolution of plumage and feathers in dinosaurs.
His curiosity aroused, Pascal assembled a team to search the site for themselves. It's a lengthy process, requiring a deep layer of soil to be removed to get to the fossils. But after several days, the team's work starts to show results.
Look at that. That's quite a big deal. Just there, at the edge. Oh, wow. That's one. So here, at the edge of the plate, you can see very fine little filaments, and these are feathers, dinosaur feathers. You can see that the filaments converge towards the base, so these are composite feathers. It's a primitive kind of down that we find on some primitive dinosaurs.
Compared to the impressive Chinese discoveries, these fossils may seem a little underwhelming. But the paleontologists are thrilled to discover a completely new animal species. During the Jurassic period, the Chinese peninsula was covered in a vast forest of conifers, while Siberia was much more hostile. The arid climate had huge seasonal variations in temperature and intense volcanic activity, one of the keys to conserving precious fossils. Only fragments of skeletons are found at Kolinda. To begin with, the Russians thought that the feathers came from fossilized birds, the scales from crocodiles, and the bones from a small predatory dinosaur. But Pascal was not convinced by this hypothesis. In 2014, he reanalyzed all the fossils and suggested an entirely different explanation.
It's a bit like going into a cemetery and gathering up loose bones. You'll have small tibias, large tibias, little femurs, and big femurs. But they all have the same morphology, so we can tell they all come from the same type of dinosaur that we called Colindadromeus. Because of the large number of disconnected bones that we found at Kolinda, we now know that Colindadromeus was a small, herbivore dinosaur that was fast, slender, and agile.
This is the first ever feathered herbivore dinosaur to be discovered, a separate branch of the dinosaur family tree from the carnivorous theropods. Colindadromeus lived in herds. Just like wildebeest migrations in Africa, large predators, such as Sinraptor, must have closely followed the movements of these dinosaurs.
This is a real revolution. What it means is that all dinosaurs could potentially have had feathers.
Feathers would have appeared on an ancestor that was common to both groups. It could be as old as dinosaurs themselves, first seen in the Triassic period 220 million years ago. The misfortunes of this group of herbivores have led paleontologists to the origins of feathers. Thanks to Colindadromeus, we now know that the first feathered dinosaur, the common ancestor of the carnivores and the herbivores, remains to be found in fossil beds going back to before the Jurassic period. But who knows what other secrets could be found in Siberia? And what clues could be hidden in other parts of the world to document the early history of the bird dynasty?